Welcome to our chemistry projects. We are going to talk about radiation projects, and here our objectives. We are going to discuss what's radiation, who discovered it, properties and types of radiation, Röntgen and X-rays, and healthcare. And first, we are going to discuss what's radiation. Radiation is energy that comes from a source and travels through space at the speed of light. This energy has an electric field and has wave-like properties. You could also call radiation electromagnetic waves. And here you can see electromagnetic spectrum.
Now we are going to talk where was radiation discovered. It was the capital of Poland, Warsaw.
And on April 20, 1902, Marie and Pierre Curie successfully isolate radioactive radium salts from the mineral pitchblende in their laboratory in Paris.
In 1898, the Curies discovered the existence of the elements radium and polonium in their research of pitchblende.
So the survey time came. Here we can see a bunch of options, and we're gonna find the Poland flag. So actually, maybe you guessed or not, the first one is Singapore, the second is Indonesia, third is Monaco, and eventually D is indeed Poland's flag, where it was first discovered.
And here we're gonna discuss radiation properties. First of all, ionizing radiation. Ionizing radiation is the energy that comes out of a radioactive atom, and radioactive decay happens when an unstable atom gives off radiation and changes into a more stable atom of a different element. And radioactive atoms can give off four types of ionizing radiation. They are alpha particles, beta particles, gamma rays, and neutrons.
So the other thing we'll be talking about are basically isotopes that are also radioactive. So radioactive isotopes are basically the same atoms with different amounts of neutrons that are radioactive. Each type of radiation has different properties based on what element they are and what isotope they are actually. And the length of time varies depending on its radioactivity, and actually the way we call it is half-life. So this is the way we define radioactivity and how much time it will take for it to become. The next thing we're going to talk about is our types of radiation. And first of all, we're going to break out alpha radiation. So it's the least harmless one, and it can hardly even cause any problem to human. So it cannot go through our human skin, so it cannot penetrate through it. Moreover, alpha-emitting materials can be harmful to humans only if humans have wounds on them and if they are being protected with clothing. So radiation won't affect it as it can't even go through this. Also, radiation cannot go through water and other kind of liquids as it doesn't pass, so it can't be detected there. A thin window called GM probe can detect the presence of alpha radiation. So this is basically how we find and detect it. And it actually plays a really essential role in physics, especially quantum.
And beta radiation. I want to talk about firstly beta radiation's traveling. Beta radiation may travel several feet in air and is moderately penetrating. Clothing provides some protection against beta radiation. Beta emitting contaminants may be harmful. Most beta emitters can be detected with a survey instrument and thin window. Some beta emitters, however, produce very low energy, poorly penetrating radiation, and beta radiation can penetrate human skin to the germinal layer. And if high levels of beta emitting contaminants are allowed to remain on the skin for a prolonged period of time, they may cause skin injury.
The third type of radiation is gamma and X-ray radiation. Gamma radiation or X-rays are able to travel many feet in air and many inches in human tissue. X-rays are like gamma rays. X-rays are penetrating radiation. Sealed radioactive sources and machines that emit gamma radiation and X-rays respectively constitute mainly an external hazard to humans. Gamma radiation and X-rays are electromagnetic radiation like visible light, radio waves, and ultraviolet light. These electromagnetic radiations differ only in the amount of energy they have. Gamma rays and X-rays are the most energetic of these. Next, we're going to talk about Einstein's photoelectric equation. When photoelectrons are removed from a metal surface, a certain amount of work has to be done in removing them. Photoelectrons will lose some of their kinetic energy in order to escape the attractive field of the positively charged nuclei. The work required to remove the photoelectron is called the work function. The energy received from a photon is split into work necessary to separate the electron from the metal, the work function, and kinetic energy.
So here we can see the equation Einstein ended up with, and it describes basically the working mechanic of photoelectric equation. So it's basically energy of proton equals work done to remove the electron plus kinetic energy of the electron. So we can describe it as formula followingly. Energy equals phi plus maximum kinetic energy of equation, or energy equals phi plus m multiplied by v squared divided by 2. So as we see here, we're going to be discussing radiation and its impacts with healthcare. So it can both affect us in positive and negative ways. One of the major problems it causes is cancer. And while mentioning cancer, the main one that might appear is skin cancer, because our skin gets in contact with radiation first. In comparison with other organs of us, because they're outside. So they might cause some cells to work wrong, mutate and become tumor that can furtherly contact to other vital organs and kill us. The other one is X-rays. If you're not being under the influence of X-rays constantly, and you are just getting X-rayed a bunch of times a year or so, its radiation impact will be not that much, and we can totally ignore this as it has no harm. It can have more even profits, like being able to see our skeleton and bones. The way it works is basically our skin and flesh being less denser and our bones being way more dense. So while X-rays can pass through our skin and flesh, it can't through our bones, so the image appears. Chordoma is one of the main problems radiation causes. It's making one of the vital organs of us work the way that it's not supposed to, our spine. So it basically causes some kind of tumor in there and harms us. That can even cause death. Ultraviolet is another type of radiation, and it can impact us in a good way if it is in the right quantity. And that's why it's mainly recommended for us to be outside, especially at noon, so we can get vitamin D from that ultraviolet radiation rays.
Now we're going to talk about Röntgen and X-rays. Röntgen reported the discovery of X-rays in December 1895, after 7 weeks of assiduous work during which He had studied properties of this new type of radiation, able to go through screens of notable thickness.
So he ended up naming like those rays X-rays due to the fact that they're unknown, their nature is not known. Though it is still sometimes being called Röntgen rays, as he was the discoverer of that.
Now it's survey time again. And our question is, how does Röntgen work? First one is, they go through less denser skin and flesh and cannot get through bones, so image appears. Variant B, they go through less denser bones and cannot get through skin and flesh, so image appears. And variant C, they go through bones and skin and flesh, so image appears. And the right answer is answer A.
So we are going to talk about interesting facts about radioactivity. For many years, alchemists searched for a method to produce gold, but recently with the advent of nuclear technology, this process has actually become possible. Mercury is relatively easy to turn into gold, so it will be used as the starting material. This method is not a terribly practical or economically viable way to go about making gold, but if you are interested in how it works, you can learn the science behind the process. And here you can see a kilogram of mercury is equal to 0.73 grams of gold. And thanks for your attention. Here you can see participants. First, me, Fidan Nazarova, provided concept slides, resource and images. Second is Murat Azadali, provided main resources and all images and pictures used. And third is Asif Hamidov, provided some information and resources. And at last but not least, Iskandar Jafarli provided make slides and its design and idea.